the value for theta 1 and theta 2 like this. Okay. So for kinematics, dia terbalik. We know the value for theta 1, theta 2 and so on. We want to calculate the end position for our robot arm. For inverse kinematics, we know the end position, but we don't know the value for theta 1 and theta 2. Okay. So what is it for, the inverse kinematics? Untuk apa? Inverse kinematics, as you can see in this example, let's say I want my robot arm to follow this line here, straight line. Okay, how can I do that? I need to do inverse kinematics and calculate the value for each joint. What is the value so that I can follow this line? Okay, so I just give a command, please follow this line and calculate the joint on each point. So point ni apa dia punya joint value dia, point ni apa joint value dia. Okay, so this is one of the example for the application of inverse kinematics. Okay, the next example for inverse kinematics is we can do that. What we can do is, let's say I know where is this paper will arrive at this position here. So what I will do is I know this position for x, y, and z, and row pitch yaw are py, roll pitch yaw. So what I do, I will use inverse kinematics to calculate what is the value for all of this joint here. Okay, so kita gunakan inverse kinematics nak cari apakah nilai joint robot tu supaya dia boleh pergi ke this position x, y, z ni. Okay, so that is the concept for inverse kinematics. Now we want to go, how can we do the inverse kinematics? Okay, to do inverse kinematics, what we do first is we find the forward kinematics. So first we need to do all the process for kinematics. Okay, so we need to assign the frame for DH parameter, DH frame, and find the parameter table, put in the parameter into matrices and multiply the matrix, and we will get a matrix like H06. Okay, so we will get a 4x4 matrix. After that, from this 4x4 matrix, we can find the inverse kinematics. Okay. To do the inverse kinematics, we need to do some how do you say? We need to do some a bit complex trigonometric equation. So we want to solve that trigonometric equation. We can use this 7 trigonometric equation. So there is a derivation for this solution, and it is long, but you can look into it from the internet or somewhere else, how to derive this solution. But in this class, we will not learn how to do the derivation, but we will use this trigonometric identity to solve our inverse kinematics. Okay, and usually this 7 trigonometric equation will be given in your final question, but I think during this work from online test or final, I don't think we need to provide this equation because you can already get it by your own. Yeah, okay, kita boleh ambil sendiri buka aja kan. Okay. Okay, so this one will become the quiz for today. So let's say, given that 2 cos theta is equal to 5 minus 3 sin theta, what is the equation on this part here? Please find the equation here. And what is the solution? Okay. Okay, cuba buat. Please try it, and after this I will uh, randomly call one person to answer this question. Okay? Ataupun ada siapa-siapa nak jawab? Ada orang baru ni. Okay, Assalamualaikum Ahmad. So we are doing our first quiz. So we are trying to solve this equation here. Given 2 cos theta equals to 5 minus 3 sin theta, what is the equation on the left and what is the solution? So first we are trying to find what part of the equation, either 1, 2, 3 or 5, it is the same with the given 2 cos theta 5 minus 3 sin theta. Okay, please try this. Okay, maybe I would like to call upon siapa okay. Just a second. Okay, so I think how about maybe Atira? Okay, Atira Yusuf, can you give me the answer for the first question? Dapat tak Atira? Boleh respon?
Nak, doktor.
Tak dapat Atira?
Not yet, doktor.
Not yet. Okay, so what is your current problem right now? Apa yang sekarang yang menyebabkan tak dapat tu? Okay, Atira Yusof, kita nanti full screen Okay, kita bagi kepada orang lain pula. Siapa nak Imran Syahmi Imran Syahmi ada? Imran Syami boleh bagikan jawapan untuk yang ni? Ya, mana ya? Imran. Imran Syami pun tak ada. Imran Syahmi. Tak ada. So kita pergi kepada Priscilla lah, ya. Priscilla. Okey okey, faham. Line slow Okay. Okay Priscilla. Nampak macam Hindustan dah ada kipas besar kat depan.
Kalau dari table ambil A1 bracket B square root A square plus B square minus C square bracket minus A tan AB.
Okay. So which number? Priscilla?
Which number?
Which equation?
Number 4.
Number 4. Okay.
No.
No, okay.
Number 5.
Number 5. Yes. Okay, so what we do is we change to cos theta. We bring 5 here, so it will be -5. Maybe we don't need to bring 5, we just bring 3 sine theta, right? Equals to 5. Okay. So we just bring this one to the left and we will get an equation similar to this one. Okay, thank you Priscilla. Okay. So what is C? Priscilla boleh lagi sekejap. What is the value for C?
C.
C.
5.
Okay, good.
Okay.
Yes. And B?
B is 3.
B is sine. So it is
3.
3. Okay, good. And A is
2.
2 cos, right? So 2. So then we just fill in all the value for C, A, B, and C, and here A and B. Then we will get this equation here and here. So we can solve the value for theta. Okay, thank you Priscilla. Okay, alright. So simple just find what equation is the same with what you already have here, and then you will try to find the theta to solve the theta. Okay, so by like this is the equation you have, you can solve theta by using here this equation here. Okay, so now you already understand how to use the trigonometric equation. Okay, let's try to solve one inverse kinematics. Okay, let's say this is the first case for our robot. So our robot can move this way. So this is a linear motor going up and down. And we have a linear motor going forward and back. So this one is D1 and this one is D3. And we have a rotational motor which is a theta2 that can turn this robot to the left or to the right. So we have 3 motors. 1, 2, 3. Okay. It is given that the DH parameter for this is this one. So there are three links. So we have theta 2 moving motor, D1 and D3. If I give a position for this robot, which is this position here for X, Y, and Z, and we go inside our inverse kinematics will give out the value for D1, D3, and theta 2 as the output. Okay, so inverse kinematics will give the value for each motor. Okay, okay. So now we know that there are three moving motor, and this is the position for the end effector. Okay, and this is the value for Py, Px, Pz. Okay, okay. Let's say our frame is like this. X. This is X frame, and this is Y, and this is Z. So this is the value for Z, this is the value for X, and this is the value for Y for the end effector position. Okay. And the Px, Py, and Z is given. We know this value. Okay. Kita yang tentukan value kat mana end effector tu berada. We determine that value Px, Py, and Pz, and then we want our computer to calculate the D1, D3, and theta 2 for this robot. Okay, so first we already know the Px, Py, Pz, but we need to find the Px, Py, Pz in the forward kinematics equation. Okay, then we need to find the value for each moving motor. Let's say we want to find the value for D1, D3, and theta. So by doing that, we can solve our inverse kinematics. Okay. Okay. So the step is simple. If you want to find a D, linear motor, you just need to multiply Px and Py by power by 2, and you can plus the Px and Py together. By doing this, you can actually eliminate all the sine, theta, and cos theta in your equation. So you will only have the value, you will delete all the trigonometry value. Okay. So first you need to multiply Px and Py to become Px power by 2, Py power by 2. And then you need to either add or minus the Px and Py to minimize your equation, or to delete all the trigonometry equation. Okay, and finally you can solve uh, your problem. I mean this one maybe you don't need to use trigonometry equation. Okay, so just do 1 and 2, you can also already solve your inverse kinematics. Okay, for the next one, if you are trying to solve a theta equation, you are trying to find a theta solution. To do that, you need to multiply your Px and Py with sine and cos theta. Let's say you want to find theta 1, so you need to multiply Px with sine theta 1, Py with cos theta 1. If you want to find a theta 2, you need to multiply by Px sine theta 2, Py cos theta 2. Or you can also do it another way, Px cos theta 2, Py sine theta 2. Kita ubah, we just change from cos to sine. Okay. Then you will need to subtract or add between these two equations. What you want to do is you want to minimize the equation. After you minimize this equation, then you will find a similar equation to the trigonometric solution, and then you can solve your equation. Okay, so this is just the overall. Now we will do. Now we will see how we can do this. Okay. Okay. Let's say you already multiply your robot forward kinematics. You have done the dynamic Heisenberg, and you will get this forward kinematics equation, which is h0 to 3. And if you remember, this part of the equation is the rotational value, the roll, pitch, and yaw for your n effector. How about this value? What is this value? Do you remember? What is this value? What is this value? What is this value? Okay. So I give you about 30 seconds, and then I will call one person to try to answer this. Okay. Okay, Nur Amalina. Nur Amalina, ada tak? Nur Amalina binti Nur Pisang. Ada tak? Nur Amalina tak ada eh? Nur Amalina binti Nur Pisang. Ada ni. Senyap je. Toilet eh? Toilet kau eh? Macam korang ni eh. Okay. So this time kita ambil Nur Izwana pula eh. Nur Izwana, can you tell me, oh sorry, tak ada jawapan dah eh. Can you tell me what is this part here?
Yeah.
What is this part here?
Directional.
Okay, good. Very good. So for directional, we have X, Y, and Z. So what is this value here? This is for
X.
X. This is for
Y.
Y, and
Z.
Z. Okay. So this is PZ, PY, and P. Yes. Okay. Thank you very much. Izwana.
Yeah.
Okay. Okay. Thank you very much, Izwana. So what we do here is we can get the value for Py, Px, and Pz by looking at this equation here. Okay. So looking at this equation here, we can get the Px, Py, Pz. And now we know that the Px, Py, and Pz is given. Next, we want to find the robot joint. If you remember, our robot joint have 3 joints, which is B1, theta 2, and B3. Okay. The first one, I want to find D1. Okay. So maybe we can solve D1 here. What is the value for D1? So D1 is equals to PZ, right? And we already know the PZ value. Okay. So D1 is equal to PZ. Therefore, we can already solve our first equation. Okay, maybe here. Okay. So we can already solve our first equation because D1 is equal to PZ. Do we know the value for PZ? Yes. Because we determine the value for PZ. Kita yang bagi. berapa PZ. So if the PZ is maybe 0.5 meter, so D1 motor will move 0.5 meter up. So let's see on this picture here. PZ is equals to D1. So if PZ is 0.5 meters, so the D1 will also become 0.5 meters. So we can solve the inverse kinematics for D1. Senang kan? Okay. Okay. This one we already solved D1. Next, we want to solve D3. To solve D3, if you remember, what we need to do is we need to power px2 by 2, py2 by 2. So then we can either plus or minus between these two equations to minimize it. Okay, let's do this first. Let's power by 2x. So x, when we power by 2, so I hope everyone is doing together with me. Okay. Okay. So this is our px. So px powered by 2, it will become negative d3 s2 plus a2 c2 multiplied by negative d3 s2 plus a2 c2. So what we will do is we will multiply like this. Oh, sorry. Multiply this one with this one, this one with this one, this one with this one, and this one with this one. So it will become like this. So negative d3 sine theta 2, we multiply with negative d3 sine theta 2, it will become positive d3 power by 2 and sine theta 2 power by 2. Okay. Next, we multiply this one d3 with this one here. So it will become negative d3 a2 s2 c2. Okay. And then we multiply this equation here with here. We will have the same thing again. d3 a2 s2 c2. This one is the same, so we just put this one front 2. Okay. Tambah je kedua-dua dia. We just multiply these two. Not multiply, we just sum of these two equation. So it will just become 2. Okay. Next, we multiply this equation here with this equation here. It will become a2 powered by 2, c2 powered by 2. So this is the equation for px2. How about the py powered by 2? Same thing. So we just do this equation here again. d3 c2 plus a2 s2 d3 c2 plus a2 s2. So what we will get here is this equation multiply with this equation here, we will get d3 powered by 2 c2 powered by 2. This equation here multiply with this equation over here, so we will have d3 c2 s2 and a2. And then we will multiply this equation here with this one here. So it will be the same. Sama kan? S2A2. So this one is the same with plus. So this is 2. And this equation here multiply with this equation here, we will get A2S2. So then can get the equation for Py2. So this is our equation for Px powered by 2. This is Py powered by 2. Okay, do you notice something something similar between these two equations? What happens if we plus these two equations? Okay, so maybe someone can help me with this equation here. Siapa dapat? So kita tanya Hagilan. Okay, Hagilan. From these two equation here, can we minimize these two equation? Boleh kita kurangkan dia?
Boleh doktor.
How? How can we do that?
Pythagoras theorem.
Okay. Maybe we will not go to that way, but that is one alternative. One way we can plus Px2 and Py2. So this one plus, this one plus, and this one plus, right? So what happens if we plus this one with this one here?
Yang dua tu hilang doktor.
Yes, it is the same. Okay, good, Adilan. So these two is the same. Okay, sama kan? Alamak, sama, senang. So because it is the same, we can just cancel these two. Now we just need to plus this part here. So when we plus these two here, we will get this one. Kita plus these two here, we will get this one here. So what we will get is D3 powered by 2, C2 powered by 2 plus D3 S2 powered by 2. Kan? So we take out the D3 here and we will get this equation, which is the same with this one here. So if we have this equation here, what does it mean? Sin kuasa 2 theta plus cos powered by 2 theta is equal to what? Siapa ingat? Nak tanya siapa pula? Let's try. Okay. Nur Suhada. So
Ya, doktor.
sin theta powered by 2 plus cos theta powered by 2 is equal to what? Okay.
Tak ingat lah doktor.
Maybe it's a bit hard, but actually the answer is simple. Is equal to 1. So this is a trigonometry identity, okay? So if this sin theta powered by 2 and cos theta powered by 2 plus is equal to 1, so this one will become apa dia? Suhada? Apa tadi?
Ulang balik.
So this one is sin theta and cos theta is equals to 1. Okay, done. So this equation here, what will happen? Apa yang kita boleh buat? Sama tak?
Dia sama. Dia jadi satu lah.
Yes, we can cancel it to become 1. This one is also the same, we plus it and we take out the A2 and we will get sine theta, sine theta 2 power by 2 cos theta 2 power by 2. Dia sama tak dengan ni?
Sama doktor.
So we just cancel it, it will become 1.
8.
So now erase all the ink. So now dia kotor sikit. Saya bersihkan sekejap. Okay. So now this equation has become simple. So finally we will get d3 power by 2 plus a2 power by 2 equal to px power by 2 py power by 2. The value that we want to find is d3. We already know the px and py, and we already know the a2. A2 value is the joint value, the link value of the robot. Okay, dia berdasarkan robot. It depends on the robot model. Okay, so okay, this one we already know. This one we already know. This one we already know. So we just want to find the d3. This is the unknown. So what we do, we bring a2 to the right. So it become negative a2 here. And powered by 2, we just bring it to the right. So powered by 2, it become root square. So then we can solve d3. Okay, now we already solved d3 here. We already solved d3. The final one that we need to solve is a2. So how can we find a2? If you remember, a2 is a theta. If you want to find a theta, you need to multiply your px and py with sine theta and cos theta. Okay? And then you need to subtract this equation and finally find the solution using 7 trigonometric solution. Okay, let's try this one. Okay. So so px and py is this one. This is px and this is our py. So this is our px and py. Next, we need to multiply px with cos, because this is theta 2. So we need to apply by cos theta 2 and sine theta 2. And then we need to either minus or plus. Either way is okay. What we want to do is we want to minimize. We want to make the equation smaller. Okay, so let's multiply this one with cos theta 2. So what will happen is we will have px cos 2, it will become cos 2 negative d3 sine 2 plus a2 cos 2. So it's simple. So it become negative d3 s2 c2 plus a2 c2 powered by 2. Okay, next we want to do sine py multiplied by sine. So py multiplied by sine 2, it will become sine 2 multiplied by d3 c2 plus a2 s2. So it become d3 s2 c2 plus a2 s2 powered by 2. Okay, then so this one will go here, this one will go here. Okay, do you notice anything that is similar here? If we plus this one here and here and here, okay, do you notice something similar here? Okay, okay, please try to find anything that is similar here. Okay, let us someone that is not in the picture. Nur Amalina, are you still in your toilet? Oh, Nur Amalina. Tak ada Nur Amalina? Muhammad Imran. So, Amalina. Kita keluarkan dia dulu. Kalau dia ada, dia akan masuk.
Ada.
Oi, okey. Okey, baik. Okey, Muhammad Imran. Okay, Muhammad Imran. So here,
Yang lain nak buat, nak open camera doktor. Nanti dia putus.
okay, it's okay. So Muhammad Imran, what happened if I plus these two equation here? Do you notice anything that is similar? Ada tak benda yang sama kat sini antara kedua-dua equation?
Nanti yang dekat yang negatif D3 dengan plus D3 ni akan hilang doktor.
Yes, good. Very good, Muhammad
Boleh
Syami.
Boleh potong.
Okay. Boleh potong So what we will get is only A2 C2 plus A2 sin theta 2 plus Px C2 plus Py S2. Okay. So this one we can take out the A2 out, kan? Right.
Ya
Sama
doktor. Buat try.
So, kan A2 C2 power by 2 plus S2 power by 2. So this one sama dengan apa? Is equal to what? This one here.
Trigonometric identity doktor.
Dia sama dengan?
Satu
Yes, good. So this one is equal to 1. So we will get A2 is equal to Px C2 plus Py S2. Okay. So nice. Okay, sikit lagi Syami. So this one maybe we can solve using 7 trigonometry solution Okay. So which of this equation is the same with this one? Mana satu? Nombor berapa? This one?
Nombor
This one?
tengok jap.
Tak sama kan? Nombor 3 sama tak? Tak sama
Tak.
Nombor 4 sama tak?
Nombor 4 tak sama.
Negatif kan? Tak sama. It's not the same because of negative. Number 5?
Nombor 5 macam betul.
Yes, okay, good. Sami. It's correct. Betul. So the answer is the same with equation 5. So we use equation 5. So equation 5 is A cos theta B sin theta. Okay. So Syami, can you tell me what is the value for A? What is the value for A from this equation here?
PX.
Okay. B?
B PY
and C
C equal to A2.
okay A2. So okay, complete. Now what we do is we need to put our value into this value here. Okay. So kita pergi balik belakang. So we use this equation here and we find the CBA and put that value inside here and we can get the solution for theta. What is theta? So here we know the value for A2 is we know the value for C. C is A2, A is Px, B is Py, negative A2. So this one is Px and Py. So finally we get this equation here as our answer. So we know the value for Px, right? We know the value for Py, we know the value for Px, Py, A2, we know this is the link value for the robot. Ni nilai panjang robot tu, model robot So kita tak boleh ubah, dia tetap. So we know the value for A2. So by just giving the value for Px and Py, we can find the value for theta here, for theta 2. So now we already solved all of the join. So now we can do the inverse kinematics for this robot here. Last kita pun dapat selesaikan this robot here. So by using inverse kinematics, we just need to put in the value for Px, Py, and Pz using our inverse kinematics. If you remember, D1 value is equal to Pz, D3 value is equal to and theta 2 value is equals to the equation that we have before. So by using this equation here, we can calculate all of this value. Now we will know what is D1, D3, and theta 2. So we just move our robot joint to follow this D1, D3, and theta 2 value. Then the robot will move at the Px, Py, and Py position. Okay. So kita bagi the inverse kinematics here. We just use our inverse kinematics equation. We can calculate what is the value for each joint. And then we just put this value of the joint and the robot will move to the position that we want. So it will become something like this. So by using inverse kinematics, we can put the value for Px, Py, and Pz here. Then the robot can find the equation for all the theta here and the robot can follow this line. Okay. For this example, we give the value for Px, Py, and Pz here. Then the robot will calculate the value for each of the robot joint. Okay. So robot tu dia boleh pergi kat mana yang kita nak. Okay. So okay, we complete for this first example. Next, we will try to do the inverse kinematics for another robot arm. Okay. Okay, saya tengok sekejap